Hello and welcome to ElectroPHY channel. In this video, we want to introduce you a simple single-phase generator, then extend it to three-phase. In general, you will learn the physics behind the electrical generators. First, you should know about Faraday's law of induction and Lenz's law. Faraday's law explains about induction of voltage and current in a closed loop due to the changing of a magnetic field, and Lenz's law indicates the direction of the flowing current. If you want to know more about these laws, we refer you to our another video which we explained and experimented in more details. First, consider a simple loop wire which can rotate around this axis. Loop wire ends are connected to a slip ring, which means that we have access to them. Also, there is a capacitor connected parallel to the loop ends. Here our source is Earth magnetic field. We don't use any extra source. The magnetic field direction of Earth is as shown. Now you may guess the experiment. We want to rotate the loop. Therefore, the Earth magnetic field flux, which goes through the loop, changes by the time, and due to the Faraday's law, a voltage is induced in the loop, which we can see it with an oscilloscope. But what is the role of capacitor here? The capacitor eliminates the high-frequency electromagnetic noise and lets us measure the voltage induced by the Earth magnetic field. In fact, capacitor impedance has a reverse relation with frequency. So as the frequency goes up, high frequency voltages will be shorted. Here you can see equivalent circuit of explained setup. We measure the voltage of capacitor. Here we have a better view of the slip ring and the capacitor. Now let's do the experiment. As you can see, the rotation of the loop has made a sinusoidal wave, so we have made a simple generator. What if we disconnect capacitor from the circuit? Let's see. In this situation, as you can see, the waveform is very noisy. Well, real generators don't need this capacitor. It's just in our case to show a better waveform. Let's consider the filtered waveform in detail. As you can see, as the rotation speed of the coil reduces, their induced voltage will be reduced as well. That's because the dφ to dt in the Faraday's law equation is reduced. In the other word, the change in magnetic flux through the loop is decreased due to the decreasing speed of the loop. Also, you can see that the frequency of the sinus waveform is decreasing, or the time period is increasing. That's also due to the decreasing speed of the loop, because the frequency of the generated voltage is related to the speed of rotation, the same thing as it is in real generators. Now let's consider a three-phase model. Its concept is as the same as the previous single phase we discussed. The difference is that we have 3 coils, 3 slip rings, and 3 parallel capacitors. You can see that each pair of coils have a 120-degree angle difference. This mechanical phase difference will make a standard 3-phase voltage. Here the equivalent circuit of the 3-phase generator is shown. We will measure voltages of capacitors with oscilloscope. Here you can see a 120-degree angle difference of 3 coils. The 3 coils have star connection, and here you can see 4 slip rings, 1 for common end and 3 for each phase. And here you can see 3 capacitors for each phase. Let's rotate the generator. Remember that here the Earth magnetic field is again our source. You can see that 3-phase voltage is generated. Like the single-phase generator, the amplitude and frequency of the 3-phase waveform is decreased as the speed of rotation is decreased. Special thanks to Professor Mohseni, head of Electrical and Electromagnetics Elementary Lab of Tehran University. Thanks for watching. Hope you learned good things. If you like this video, hit the like button and subscribe to support our channel.